Okay, welcome back. This time we are doing scheduling. Scheduling and cost go hand in hand. There are constraints on each other. You can't have more schedule than you have cost to accommodate, etc. So, jumping in a couple of quick terms. One is critical path method. That's the way of determining the schedule. A couple of terms go with it. That's the shortest path that you will use to complete the project. It's also the longest path in the project. So it's called the critical path. It's not critical because the activities on it are so critical. It's because they have no float. They have nowhere to go if there's a delay. That's what makes it critical. And PERT, I mentioned, it was also a tool to reduce risk in cost management. Yes, I can use the same tool, PERT, in schedule management to reduce risk. Now, this is a conversation you're going to want to have. You're going to want to go out and get scope first, all your requirements, like from a business analyst, and you're going to make sure that the cost management comes in and your schedule folks, and you want to integrate all these together into that iron triangle, your three baselines: scope, schedule, and cost. They all must match. And you will spend the rest of your time as a project manager making trade-offs between scope, schedule, and cost baselines. And so those are the only three baselines, and you have to manage them. Now, most of managing it will come through, we'll start with a work breakdown structure, which is all about scope, but you will decompose that. You'll break it down. You'll decompose it into your activities that support your schedule along the way. And that's how you'll come up with your schedule activities. You're not adding to the work breakdown structure. You're detailing out the work packages in the work breakdown structure for what specific activity do I need. For example, if I need to build bike tires, well, one work package would be front tires and one would be back tires. And from there, that's all I need. I need to deliver those in my work breakdown structure, that's scope. But now I need to go out as an activity and purchase the materials. I need to assemble the materials. Those are activities that support building that work breakdown structure work package. And so you'll come up, once you get all those activities, you'll come up with a network schedule, right? And network scheduling has advantages. It's consistent framework that a lot of people are familiar with. It does show interdependencies. A work breakdown structure did not show interdependencies. It showed deliverables that must be completed to finish the project, but not interdependencies between them. It's also going to show the resources you need for each activity along the way. And it's going to be a good tool to communicate with others. And it's going to identify your critical path activities, the activities that have no float, no extra time built in. That's not padding. The other activities on the schedule have to wait for critical path items, and that's what gives them an extra day or two, for example. Okay. So some more advantages here. I think it's reflected well in the book. Notice the bottom one, though, right? I need probabilistic estimates. I need estimates that are not padded, that are accurate. And just like in cost management, I want my people doing the estimate. I want them giving me a basis for their estimate. Tell me why you determined that, so I can make sure there's no fat in there, and I can compare it to lessons learned later if it was off. And also, here's a rule of thumb that the person that will run the process, the activity owner for each activity, that's the one that should be leading the estimates, because they know the most about it and they have the most invested in it. So some scheduling techniques include ADM and CPM. Those are both really types of precedence diagramming method, or PDM, right? So we're going to focus on CPM in this course, critical path method. Again, critical path method reduces the risk of your schedule going awry. PERT reduces the risk of your schedule going awry. It was part of a military project back in the late 50s, early 60s. A little bit of history about it. But we bring PERT as a way to estimate an activity, and each activity forms together in a schedule to create the critical path method approach that we're going to use. And that's how they work together. So an activity is that task under the work breakdown structure that must be, so you have to buy the equipment for the tire, you have to have somebody assemble the tire, somebody pump up the tire. Those are all activities that will happen in a certain order. And you will complete them by using the network, which we generally draw from left to right with connections that we call a predecessor, the previous activity, and a successor, the next activity. Okay? The path along itself are where those activities connect. And we said that a critical activity is not one that was more important than the others. That doesn't make it critical. It's an activity on the path that if that activity delays, because we're talking about the schedule, that delay will delay the entire project, right? And you piece those key activities together, those critical activities together, and you end up with a critical path. So here's what activities might look like, right? You have a start activity, a continue activity, and an end activity. And notice we are piecing them together. These are called dependency arrows. So type 3 continue has to happen after type 1 starts. So this has to start and finish, then this starts and finish. Then the dependency arrows, so this starts and finishes, right? We get a sequence, and that was called activity on node. The activity is happening right on the node, not in the dependency arrow in the middle. The activity is happening here. Now, there is the activity on node, which we're going to use in critical path method. Consider them synonymous for this course. But activity on arrow is where the activity happens in the middle, in between the nodes. This used to be very popular when scheduling is done for major projects by hand, but now that it's done largely by computer, you'll work some of these by hand now just to get used to them, the variables, the constraints, but we will do activity on node, which is also the critical path method. Our activity work will be right on the actual node. And the boxes there are called the nodes. Okay, so we begin with the start activity and we'll add times up together. So notice the start activity, and then I've got a couple of other activities. So notice here, if my start activity is day 1 and it takes 1 day, I will get day 2 here. But if this dependency arrow leading to this activity takes 2 days, I still start at day 1, but now it's day 3 when this is done. And you can see how activities now create a difference, right? That one is closer to the critical path because whoops, what happened there? This activity has some, this activity is going to have to wait around for this one to finish. It's going to take longer, okay? And then by doing that, I end up adding activities with the, this is a predecessor, successor, predecessor, successor. This now A is a predecessor to C, which is a successor, and B is a predecessor to the successor D and successor E. I said these were dependency arrows, so A must happen before C gets done. B must happen before D and E can get done. Then when I add times to them, I can figure out how they work. And so I begin to construct these together in my activity on node or my critical path method. And you can see this is called a schedule network diagram. I now have a diagram of relationships between all these activities and their dependencies. This one must start before these two can start. But this one, these two must finish before this, after this one, that sort of thing. So you see the dependencies forming. Another way to show the schedule is to use a bar chart. A bar chart for this course is synonymous with a Gantt chart. There's some minor differences, but not significant here, created by Henry Gantt, and it's easy to read. It has advantages and disadvantages. It's not something I would use for large complex projects with my team because it's difficult to follow when it has complexities, but it is a good tool to brief the senior leadership, for example. Here's a picture of a Gantt chart, and it shows, you can see activity here with dependency arrows here, and the next activity here, and dependency arrows. And so it's a useful tool. This is a Microsoft project. We'll create Gantt charts. There's a very inexpensive tool that you could purchase yourself if you want. I use my own version for $170 a year, $150, something like that. It's called Smart Sheets, and if you want to Google Smart Sheets and look at a free version, it's really an Excel spreadsheet on steroids. That's what Microsoft Project is too, but that's Smart Sheets that you might want to look into. And it'll give you that same network diagram view that we were looking at before. And now I'm able to add my activity estimates to each of those nodes on the schedule, and that will allow me to create a time set of times for each activity. So here's activity A through J. You can see this is using PERT. I have my optimistic time, as you saw in the reading, my most likely time, and my pessimistic. And I can, of course, this is about to A and B and C. There were no predecessors, right, in the approach that we looked at, right? And so that's what that is indicating. But yet activity D does have a predecessor of A. Useful information. So now I have my schedule network diagram. These are nodes. These are dependency arrows. You can see that my successor to the start is A, B, and C. My successor to B is E, F, and G, etc., until I get to the end. Somewhere in here is my critical path. Activity on node is critical path method, and both are considered precedence diagramming methods, because you can see the precedence here, right? That start must happen before A, B, and C. There's a precedence set up, and that's how it gets its name. Now we can calculate the activity times. There's the formula in the book. This is the PERT formula, and basically it's just the optimistic plus the pessimistic plus the most likely time, and we weight the most likely by 4. Now PERT divides by 6 because it's an average. It's a simple mean. And so I have 6 variables up top in the numerator, 4, 5, and 6. So I divide by 6. That's all I'm doing. And then if I want to get the standard deviation, this was all in the reading, is equal to my standard dev squared. Or it's also equal to the pessimistic minus the optimistic divided by 6 and squaring that along the way. So that's PERT. There's more in the book on that. And so these would be the results using PERT in that previous slide that I showed you. So we took this chart and figured out the estimates based on the PERT, which is most likely plus pessimistic times plus pessimistic plus optimistic plus 4 times the most likely divided by 6. And that's how we got these estimated times for each activity along the way. The variance was the sigma squared, or standard deviation, and we also had the formula for standard deviation. Now, Parkinson's law, the last thing I'll tell you, this will impact your schedule. That's when work expands to fill time. I'll come back and talk a little bit about more about that in a minute.